Are you a student who is going to start the IB diploma program in the coming year? You must have chosen one of the 4 options for mathematics, analysis and approaches, or application and interpretation, either HL or SL in one of them. Whichever course you have chosen for mathematics, you are expected to have a thorough knowledge on certain concepts before entering the course. These concepts are listed by the IB in their subject guide for mathematics as prior learning topics. The topics covered here are numbers, algebra, functions, trigonometry, geometry, statistics, and probability. The concepts listed here will not be taught in your DP lessons, and not knowing these might slow down your learning process. Hence, I have decided to walk you through all these concepts as quickly and as effectively as possible in the next few videos. I will cover 1 or 2 topics in one video and give a brief explanation of each concept. If you need any detailed explanation of any concept, you will be directed to the links to that video in the description box below. Welcome to Ganitika.com. This is a website for mathematics lovers, learners, and leaders. In this video, we are going to see the prior knowledge topics on geometry and trigonometry. This is for IB Maths AA or AI, HL and SL students. First of all, let's see the topic on geometry. Under geometry, the first thing that you should have known are some theorems. The theorems here are Pythagorean theorem and its converse, and also something called triangle sum theorem. The Pythagorean theorem is very simple, you know that already. Sum of the squares on the sides of a right-angled triangle is equal to the square on the hypotenuse. Simply speaking, if you have a right-angled triangle like this here, and if you have A and B and C are the sides of the right-angled triangle, where C is the hypotenuse and A and B are other 2 sides, then according to the Pythagorean theorem, the sides, square of the sides, right, A square and B square, adding them should be equal to the square on the hypotenuse, which is C square. So A square plus B square should be equal to C square is Pythagorean theorem. And the converse is going backwards, right? If you have 3 numbers which satisfy this condition, A square plus B square is equal to C square, then those 3 numbers form the sides of a right-angled triangle. So if you have 3, 4 and 5, for example, 3 square plus 4 square is equal to 5 square, and if you have a triangle with the sides 3, 4 and 5, this triangle has to be a right-angled triangle according to the converse of Pythagorean theorem. And what is triangle sum theorem? The name looks intimidating, but the theorem is very simple. It states sum of the angles of a triangle is equal to 180 degrees, 180 degrees. If you have a triangle like this, and if the vertices are A, B and C, then the angle at A plus angle at B plus angle at C is equal to 180 degrees, which means these 3 angles added up together always give you 180 degrees. Whatever the triangle is, it is always going to sum up to 180 degrees. This is only on the plane surface. If you are having a curved surface, this is not going to work. So this theorem is applicable only on a plane surface, and this concept will be used in your TOK lessons. So keep in mind that you can use this in TOK classes as well. The next thing that you need to learn in geometry is some of the geometrical concepts such as point, line, plane. What is a point? What is a line? What is a plane, etc. And you might have to learn about the components of circles. On inside the circle, what are the different components you have? And what about angles? How to measure angles? And what are the different types of angles you need to know for under the geometric concepts for your prior knowledge. And the next topic is distance between 2 points in coordinate geometry. So if you have 2 points given, what is the distance between 2 points? There is a formula for that, which I will be giving you when I am discussing this part of the concept. The next part is midpoint formula. There is a formula to find the midpoint of 2 given points in coordinate geometry. So this is also we are going to discuss soon. First, let's talk about point, line and plane. What is a point? A point is denoted by a dot, something like this, but it should not have any dimensions. But here what I have shown as point has some area inside that, but it should not be so. When you put a pen on a paper, that much is what a dot is. So that a small dot is a point. It should not have any dimensions. It should not have any length or width or area inside that. So a point is just putting your pen on the paper with a dot. Next is it represents a location on a surface. So if you see here, the green dot, the green point in fact, represents the location just above the box, whereas the red point represents the location just below the box, and so on. So every point represents a location on a surface. We also say that in English, right? Pointing towards something, right? So it points towards a location. So every point represents a location on a surface. Next is lines. What is a line? It's the shortest straight path between 2 points. So it should be a straight path between 2 points. And because it is straight, it is going to be the shortest path. Next, it has length, but it doesn't have any width. And it extends on both the sides infinitely. Okay, this is a line. What is a plane? A plane is a flat surface and it is two-dimensional. It has length and width. Something like this as I've shown here. And it also extends on all the sides infinitely because it has length and width and it is two-dimensional. It is a flat surface. It extends all the sides infinitely. So this is something that you need to know because you will be learning more about point, line and plane in a different concept in DP classes. So are you ready to go to circles now? Circles. What are the components of circle? This is a circle. Of course, we know that this is a circle. The most important component of a circle is center and radius. Without this, you cannot make a circle, right? The center of the circle is important, and without the radius, you do not know how big the circle is. So center and radius are the most important components of circles. And you also know that this is a diameter. Diameter is the line passing through the center and touching both the ends of the circumference. And if you have the same line but not passing through the center, then the line is called a chord. This chord cuts the circle into two parts. One part is here, one part is on the other side of the line, which I'm not showing with the shaded portion here. I'm only showing one side of the chord here. This space, which is cut by the chord on the circle, is called a segment. So there are two segments when a chord cuts the circle. One segment here, which I've shown in blue, is minor segment. On the other side of the chord, which is very huge, it is called the major segment. The next is the total angle inside a circle is 360 degrees. And this is a shape which is very important to note inside a circle called a sector. This is similar to the piece that you cut out of a pizza, right? So this is called a sector in geometry. The sector is formed by two radii and a part of the circumference. So this is called a sector. Again, sector and segments are very important in DP classes. So make a note of this. One more component is semicircle, which is half the circle. The part of the circle just on one side of the diameter is called the semicircle. I hope you understood all these components of a circle. Make a note of this on your notebook so that you can have a quick reference when you go to DP classes. How do you measure angles? What is angle actually? Angle is formed between two straight lines when they intersect at a particular point, and the angle is formed at this point, right, where they meet. And how do you measure angles? You use an instrument called protractor. You keep the protractor like this on the point where they intersect and you look at the zero so that it coincides with one of the lines, and then you see how far the other line has gone on the protractor. In this case, you can see it is 37 degrees. So the angle between these two lines is 37 degrees. And protractor can measure in degrees. There is another unit called radians, which you will be learning in DP classes soon. These are the types of angles that you can have. The first angle you can see that is less than 90 degrees, right? It's smaller than 90 degrees. The next one is equal to 90 degrees. It's exactly equal to 90 degrees. Question C, the figure at question C is little more than 90 degrees. But if you see question D, it is more than 180 degrees. And question E has equal to 180 degrees because it's on the straight line. It is equal to 180 degrees. So A, B, C, D, E are the different types of angles that you can form between two lines. But we have names for these angles. With the angle which is less than 90 degrees is acute angle. 0 to 90 degrees is called acute angle. Exactly equal to 90 degrees, it's called right angle. The angle which is more than 90 degree but less than 180 degrees, it's called an obtuse angle. The angle which is more than 180 degrees is called a reflex angle. And exactly equal to 180 degree. You know it is on the straight line, right? Therefore, this is called a straight angle. 180 degrees is called a straight angle. 90 degrees is called a right angle. Acute and obtuse and reflex angles are the other three types of angles. So if you are comfortable with this, you can proceed with this video. But if you have not learned angles before, click on the link given in the description box below to learn more about angles, its basic ideas, types of angles, how to measure them, and how to construct angles using protractors, etc. All these information are given in the YouTube videos, the link for which is given in the description box below. Also in the website ganitika.com, you can read everything about angles, definition and notation, types of angles, measuring and constructing angles, angles between two parallel lines and angles in a polygon, etc. can be understood by visiting the website ganitika.com. Please register in this website with your name and email ID, and then you can read all these information easily. One of the most important formulas that you will be often using in DP classes is the distance formula. This formula gives you the distance between any two given points. Say for example, I have point P which is x1, y1 and point Q which is x2, y2. These 2 points are given. How to find the distance between these 2 points? So the distance PQ is given by square root of x2 minus x1 the whole square plus y2 minus y1 the whole square. So what you are doing is you are finding the difference between the x coordinates of P and Q, squaring it and adding with the square of the difference between the y coordinates of P and Q and finding the square root of that. This is what you are going to do for finding the distance between any 2 points. So if these 2 points are given, can you find the distance between these 2 points using the formula just given above? Pause the video here. You can find the distance using the formula above. The formula gives you the distance to be square root of 5 minus 3 the whole square plus 2 minus 1 the whole square, which will give you the answer to be equal to square root of 13. So the distance between 3 minus 1 and 5 2 is equal to square root of 13. Proceeding further, we'll see what is midpoint formula. What is midpoint of two given points? What is the coordinate of a midpoint of two given points? If R is the midpoint of P and Q and the coordinates of P is x1, y1 and coordinate of Q is x2, y2, what is the coordinate of R which is the midpoint of P and Q? This is what we need to find using this formula. The formula gives you that x is equal to x1 plus x2 over 2, which means we are going to add the x coordinates of P and Q and divide by 2 to get the x coordinate of the midpoint. Similarly, you can add the y coordinates and divide by 2 to get the y coordinate of the midpoint. So these are the two coordinates that you get for midpoints from two given points. So for example, if you want to find the midpoint of 8, minus 5 and 4, 1, how will you find it? Use the formula and find the midpoint. Are you ready? I'm going to give you the answer now. For x value of the midpoint, you need to add the x values of the 2 points, 8 and 4, and divide by 2. For the y coordinate of the midpoint, you need to add the y coordinates of the 2 points, negative 5 and 1, and divide by 2. Once you simplify this, you will get 6, negative 2 as the midpoint for 8, negative 5 and 4, 1. This is very simple, right? You just need to remember this midpoint formula. You may not be taught this in your DP classes. So better remember this: x1 plus x2 over 2, y1 plus y2 over 2 will give you the midpoint of x1, y1 and x2, y2. Are you ready to go further? The next set of topics is on geometric shapes. Different shapes in geometry. Plane figures. You have to find the perimeter and area of different plane figures. I will be showing you different types of plane figures now, and then we will find perimeter and area of these plane figures soon. Next topic is properties of triangles and properties of quadrilaterals. We'll be discussing them in detail. And three-dimensional shapes, I'll give you different three-dimensional shapes, and then we will find the volumes and surface area of these shapes as well. So this is what we are going to do under geometric shapes now. First is plane figures. What is plane figure? It's a figure on the plane surface, something like this: triangle, rectangle. Can you name the next one? This is square. And what is this? This is trapezoid or trapezium. A trapezium has two opposite sides parallel to each other, and the remaining two sides should not be parallel to each other. If they are parallel, it becomes a parallelogram, which I'm not showing here, but you have another plane figure called parallelogram, and we'll be seeing that soon in the next few minutes. So these are the basic plane figures: triangle, rectangle, square and trapezoids. And then we have another important plane figure, which is circle. And if you want to find the perimeter of a figure, you just need to go around the figure, measure the sides, add them all. So just add the 3 sides of the triangle if you want to find the perimeter of the triangle. Add the 4 sides of the rectangle, square or trapezium if you want to find the perimeter of these 3 shapes. But if you want to find the perimeter of the circle, we don't call it as a perimeter. We call it as a circumference. And the formula for this circumference is 2 times pi times the radius of the circle, r. 2 pi r is the formula for circumference, which you would have learnt it in earlier years. But just remember that circumference formula is 2 pi r. What is area of the plane figures? The area is nothing but the space occupied by these plane figures. We have to find how much space it has occupied, and for this we have different formulas for different shapes, which we are going to see in few seconds. Areas of plane figures. These are the different figures that we are going to find the areas for, which means I'm going to give you the formula for finding the areas of these plane figures. For a triangle, half times base times height is the formula, but for that we need to have the height and the base. If you have the height of the triangle and if you know the base length of the triangle, then you can apply it in the formula half times base times height to find the area of the triangle, right? This is applicable for any type of triangle, but for right angle triangle, equilateral triangle, isosceles triangle, you will have different formulas, but the base formula is this, half times base times height. From here on, you will get different formulas, and when you do trigonometry in DP classes, you will have much more different formulas as well. But the basic formula for area of a triangle is half times base times height. For a rectangle, it's just length times width, and it's easy to find for a rectangle. If you have the length and if you have the width measurements, you can just multiply them to find the area of the rectangle. And for the square, the sides are equal, therefore it is side square. And for trapezium as well, you need the height of the trapezium. And if A1 and A2 are the measurements of the parallel sides, the formula for the area of the trapezium is half times height times sum of the parallel sides. But for circle, it's easy to remember. It's pi r square. If r is the radius of the circle, we know this already. So make a note of the formulas for all these areas of plane figures, which will be very, very helpful in your DP classes. Let's proceed further to properties of triangles. So we are going to discuss the properties of triangles. The first property is triangle sum theorem, which we just learned. Angle A plus angle B plus angle C is equal to 180 degrees, which means the sum of the angles of any triangle is equal to 180 degrees. So this is something that we just did. The next property is sum of the two sides of a triangle is always greater than the third side. So for example, if you have a triangle like this, and if you add the two sides, any two sides, if you add them, then this addition, the sum of these two sides should always be greater than the third side. If it is not happening, then the triangle cannot be formed. And this concept is very important in DP classes as well. Remember this and make a note of this in your notebook. Next is external angle is equal to sum of the opposite interior angle. What is external angle or exterior angle? Sometimes we call it as exterior angle as well. How to make the exterior angle? Make an extension of one of the sides of a triangle, and the angle formed outside the triangle with that extended side is called an exterior angle. In this case, x is an exterior angle. What is the interior opposite angle to x? This angle and this angle. So y and z are opposite interior angles to the exterior angle x. According to the property, exterior angle is equal to sum of the opposite interior angle. So angle x is equal to angle y plus angle z. So this is the property that we had as a third property of the triangle. The fourth property is the side opposite to the largest angle of the triangle is the longest side. For example, if you have a triangle like this, you can see that this angle is the largest angle. Therefore, the side opposite to that angle will be the longest side among the three sides of the triangle. So the largest angle gives you the longest side opposite to it. This is the fourth property of a triangle. Let's go on to properties of quadrilateral. What is a quadrilateral? Any four-sided figure is a quadrilateral, right? Parallelogram, rhombus, rectangle, square, kite and trapezoids are some of the quadrilaterals. Compound shapes are combination of these quadrilaterals will give you compound shapes. We'll discuss this soon now. But before going to compound shapes, let's see what is a parallelogram. This is a parallelogram. A parallelogram is a tilted rectangle, right? What is this? This is a rhombus. Rhombus is a tilted square, and this is a kite. In a parallelogram, opposite sides are equal and parallel. For rhombus, opposite sides are parallel, but all sides are equal because it's a square tilted. But in a kite, adjacent sides are equal. So you can see that the top two sides are equal and the bottom two sides are equal. So adjacent sides are equal. Adjacent pairs of sides are equal, in fact. And then we can have trapezoid here, trapezium or trapezoid. In the previous case, I showed a trapezoid with both the sides slanted, right? But this is also another type of trapezoid. A trapezoid should have only one pair of opposite sides to be parallel. The other two sides should not be parallel. If they are parallel, it becomes parallelogram. So this is the only difference between parallelogram and trapezoid. So trapezoid, you have only one pair of opposite sides to be parallel. The other two sides should not be parallel. Okay, one could be straight, one could be slant, or both could be slant. That's not a problem. But as long as they are not parallel, it's okay for a trapezoid. The last one is compound shapes. If you have a rectangle like this, and if you attach another shape like this, say for example semicircle over the rectangle, you get a compound shape. Compound shape is formed by adding two or more shapes like this with each other. And now we need to find the properties of quadrilaterals. So what are the different properties of different quadrilaterals? For this I'm going to give it in a big table form, because I'm not going to discuss one by one here. It will take more time, but it's easy to understand if you go through this information from the table. You can pause the video here, take down this table on your notebook and keep it ready for your DP classes. If you have any doubts on these properties, you can comment on the comment box below and I'll be helping you on that. I hope you have taken this down. I'm going to continue with the video now. Next is three-dimensional shapes, prisms, pyramids, spheres, cylinders and cones. I didn't mention cuboids and cubes here. Why? You're going to see that soon. This is a cylinder. This is a cuboid. This is a cube. Cuboid has a base of a rectangle, whereas cube has a base of a square, and cylinder has a base of a circle. So all these three things have something common in them. They have some plane shapes in the base, and the same shape is risen all over to a given height, right? If you raise a plane figure to a height, then it becomes a prism. You can have anything as a base. For example, you can raise a hexagon to a certain height, you will get a hexagonal prism. So these three shapes are very important prisms: cylinder, cuboid and cube. The other things will be called as prism as well, but these three are given a special name. And then this is a pyramid, but you would call this as a cone. Cone is a pyramid with circular base. Pyramid is something which has a vertex on the top of the base, right? The base here is circular. So this is a circular shaped pyramid, but it is also called a cone. This is a square based pyramid, and this is a triangular based pyramid. You can see the connection between these three shapes, right? You can also have an hexagonal shaped pyramid like this. So whatever the base is, if you have a sharp edge on the top, it's a pyramid. Whereas if you raise the base to the same level, it is called a prism. So you have to understand the difference between prism and pyramid now. The most important the three-dimensional shape is a sphere, and you will be learning a lot with spheres in DP classes. So let's proceed further to see the volumes and surface areas of the three-dimensional shapes. So the shapes that we are going to see are cuboids, prisms, cylinders, compound and three-dimensional shapes. Before going further, I'm going to give you a general idea about volumes of prism and pyramid. So most of the three-dimensional shapes come under these two categories, right? Prism or pyramid. For a prism, it is base area times height. For a pyramid, it's 1/3 of the volume of the prism. If you find the volume of the corresponding prism and multiply by 1/3, you will get the volume of the pyramid. For finding surface area, you just need to add all the areas of the sides, right? All the sides and its areas. That's easy to find on the surface area. But for prism, sometimes what happens is, sometimes the top is included or not included, bottom is included or not included. Accordingly, you will find the surface area by adding the top and bottom or removing the top or bottom. So for example, if you have a cylinder or a cuboid or a cube, it's easy to understand with a cylinder. A cylinder is completely closed, will be a solid cylinder. So you will have the surface area of the curved surface plus top plus bottom, right? But if you have a tube type of cylinder where both the top and bottom are open, you will not add the areas of the top and bottom for surface area. There are cylinders that look like a can where the bottom is closed but the top is open. So in this case, you will add only the bottom area, right? So for surface area of prisms, you have to be careful which part of the prism is open or closed. So take a note of this in your notebook now. I'm going to give you the volumes and surface areas of these three prisms now. These are prisms, right? The first one is cylinder. I said prism base area times height. For a cylinder, the base is a circle. Therefore, the area of the base is pi r square. Pi r square times height will give you the volume of the prism. And for the surface area of the prism, the circular part of the prism is, or the cylinder is 2 pi r h. And top is pi r square, bottom is pi r square plus 2 pi r square. I am giving you a general formula here. This 2 pi r square part needs to be very carefully added or subtracted. As I just said, It could be open, top open, bottom open, or both open, or one of them open and one of them closed, whatever it is, depending on the situation, you will adjust this 2 pi r square part of the formula. Clear? Let's proceed to cuboid. If A, B and H are the dimensions of the cuboid, then the volume is ABH, A times B times H, which is simple, right? For the surface area, you have to add the areas of all the different sides. 2AB plus 2BH plus 2AH. So if you, again I'm insisting, if any of the sides are open or closed, you have to adjust this formula accordingly. For a cube, all the sides are equal to A, and therefore V is equal to A cube. And surface area is 6A square because there are 6 sides. A square is the area of each side. Therefore 6A square. Again, whether it is open or not, the 6 number will change as when required by the situation. Moving on to pyramid. I said pyramid is 1/3 of the volume of the prism. Now I have a cone here. What is the corresponding prism for the cone? It's the cylinder, right? Cone is derived from the cylinder because both of them have the circular base, correct? So the volume of the cone should be 1/3 of the volume of the cylinder. So 1/3 of pi r squared h is the volume of the cone. So for the surface area of a cone, the formula is pi rl, where L is the slant height and R is the radius of the base. This formula you need to remember now, but in later cases when you do calculus in DP classes, you will know how to prove this formula for surface area of the cone. Sphere. Volume of the sphere and surface area of the sphere are just formulas that you need to remember because there is no explanation that is possible at this stage. V is 4/3 pi r cubed. R is the radius of the sphere. Surface area is 4 pi r square. Just remember these 3 formulas: surface area of cone, volume and surface area of sphere. You have to remember them. Remaining things are more logical. You can remember this by logic. But these 3 formulas you just need to remember at the moment. Let's proceed further and see what's the next topic we have. Geometric transformations. So this is transforming geometric shapes, right? By translation, by reflection, by rotation and by enlargement. These are the 4 transformations that you should have known before entering the DP classes. What is a translation? Every point moves through a given distance and a given direction. What does it mean? On a coordinate axis, if you have a point, say here, and if you want to move this towards this direction and to this distance, then you have translated the blue point to the red point. So the blue point is the object and the red point is the image of the translation. So blue point is being translated to the red point, correct? This is translation. Translation is moving a point to some direction and to some distance. What you have actually done here is you have moved the point horizontally to this distance and then you have moved it vertically to this distance. So this is exactly what you have done when you are moving the blue point to the red point, right? And if I have a shape at this place, you will move every vertex in the same way to the same distance and then you will make the new image here. So the red triangle is the image of the blue triangle after the translation given. Now we are going to reflection. Reflection is a mirror image of every point on a mirror line. So you need a mirror line for reflection. So the object is reflected on this mirror line. For example, if you have an object here, how do you reflect it on the mirror line? You need to draw the perpendicular to the mirror line and then you need to measure the same distance on either side of the mirror line and then you can make the image at the same distance from the mirror line as the object. If you have an object here, you will do this for every point and then you will mark the final points, join them all to make the image of the object. Next is rotation. Rotating every point about a fixed point through a given angle. So you need a fixed point to rotate and you are supposed to be given a fixed angle. So for example, if I have a point here and I want to rotate this about the origin, this is the fixed point, I want to rotate it about the origin and then I want to rotate it over 35 degrees, okay? So I want to rotate this point about the origin through 35 degrees. How will I do this? First of all, I'll join these 2 points first and then I'll use the protractor and then measure 35 degrees from here, draw another line and stop at the same distance as the black dot and the blue dot and then I'll make the image of this blue dot. This is being rotated to the red dot now. So blue dot has been rotated to 35 degrees about the origin to the red dot. Red dot is the image of rotation of the blue dot by 35 degrees about the origin. Now if I have a figure here, I'll do the same thing for all the points and I'll make the image like this. So the blue triangle has been rotated through the angle 35 degrees about the origin, and the image of this rotation is the red triangle. Next is enlargement. The figure is enlarged or diminished by a given factor about a given point. According to the factor, whether it is greater than 1 or less than 1, the figure will be enlarged or diminished. Less than 1 will be diminished, greater than 1 will be enlarged. And this is only done on a figure, it cannot be done on every point. So if you have a figure like this, and if the fixed point is the origin, you want to enlarge this figure about the origin, right? Say for example, I want to enlarge this to the factor of 3. So what I will do is, I'll take one of the points on the figure, I'll measure this distance and extend this to 3 times the distance between the black and the blue dot, okay, because I want to enlarge it to the factor of 3. So this and this will be 1:3 ratio. So I'll extend this to 3 times the original distance, and then I'll do the same thing for all the 3 points, all the 3 vertices, and then I'll make the new triangle. This red triangle is the enlargement of the blue triangle about the origin by a factor of 3. So these are the 4 different geometrical transformations that you should have known before entering your DP classes. Next, moving on to trigonometry, which is quite simple. The first thing that you need to know on trigonometry is just basic trigonometric ratios, and then you need to know how to use trigonometric ratios to solve triangles. Okay, what are trigonometric ratios? They are sine, cosine and tan on a right angle triangle, right? So if you have a right angle triangle, you have 3 sides of the triangle, right? And if you consider this angle, for this angle, this side is opposite, this side is adjacent, and this is always hypotenuse, which is opposite to the right angle of the triangle. In this case, you have to remember the SOHCAHTOA that you learned in your earlier years. SOH is sine is equal to opposite over hypotenuse, which means sine theta is equal to opposite side over hypotenuse. And CAH is cos theta is equal to adjacent over hypotenuse, which means cos theta is equal to adjacent side over the hypotenuse. And tan theta is opposite over adjacent, which means tan theta is equal to opposite side divided by the adjacent side. So these are the 3 ratios that you need to know for trigonometric ratios on a right angled triangle. Let's proceed to see how to solve triangles using these 3 ratios. So for example, a triangle is given. It's a right angle triangle here, and you are considering this angle as theta, right? If you consider this as theta, this will be the opposite side to theta, and this will be always the hypotenuse because it's opposite to the 90 degrees, right? But in this case, if this is given to be 2 centimeters and this is given to be x centimeters, then your question could be, find the value of x if theta value is 30 degrees. Now that you have opposite and hypotenuse for theta, you will use sine value. So sine of 30 degrees is equal to 2 over x, and rearranging for x and finding the value of x, you will be having 2 over sine 30. Using your calculator, you can find that x is equal to 4 centimeters. Now the question could be in a different way. Find theta if x is 5 centimeters. In this case, x is given, hypotenuse is given. You are supposed to find the angle theta. So in this case, again, because opposite and hypotenuse are involved for theta, you will use sine. So therefore, sine theta is equal to 2 over 5, right? How to find theta from here? You need to use something called sine inverse. Using your calculator for sine inverse of 2 over 5, you can approximately say that this is equal to 23.6 degrees. So theta is equal to 23.6 degrees when x is equal to 5 centimeters in this case. And these are the types of questions that you will have under solving triangles when you are using trigonometric ratios. So this is going to be very simple, which you have done in your previous years. If you have not done them, please visit ganitika.com. Under trigonometry part 1 topics, you have everything on the basics of trigonometry. You also have YouTube video on trigonometry part 1, which deals with all the basics of trigonometric ratios. Next concept is bearings. What is a bearing? How to measure the bearing? And how to write bearing angles. Bearing is mostly used on navigation purposes. Bearing gives you the direction from one point to the other point in terms of angles. So for example, this angle is the bearing from Paris to Frankfurt. And if you want to find the bearing from Antwerp to Zurich, this is the bearing, and I'll show you how to find the values as such, but I'm just giving you what is a bearing. This is a bearing from Berlin to Stuttgart and so on. Munich to Frankfurt, you will have to measure this angle. This angle will give you the bearing from Munich to Frankfurt. So bearing actually gives you the direction from one point to another point, and it is mostly used in navigations. Now let's see how to actually find and measure bearings. For this you have to use something called a circular compass. So in this you can see that north is coinciding with 0 degrees. So from 0 degrees, from the north, you will measure the angle clockwise, and this is how you measure bearings. This is a very simple definition that I am giving you how to measure bearings. So what is the notation? How do you write bearings? For example, if you want to find the bearing from this point to this point, A to B, how do you find this bearing using the compass? Put the compass on the north like this at 0 degrees here. Measure from 0 clockwise up to the point where the B line is going. And you can see that it is 65 degrees approximately. So the bearing is written as not just 65 but 065 degrees. It's always given in 3 figures. So 065, whereas if you want to find the bearing from B to A, the protractor should be kept on B with the north coinciding with the 0, and the measuring from 0 clockwise will be this angle. So 245 degrees is the bearing from B to A, and the notation is 245 degrees because it's already 3 digits. You will give it as 245. If the bearing is in 2 digits, you will give it as a 3-digit number with a 0 in the beginning. 65 degrees is what you will say for the bearing, but when you are writing it down, you will write it as 065 degrees. So this is how bearing is being measured, and notation is given in 3 digits. If you want to learn more about bearings, there is a video about bearings, what is it and how it is measured in my YouTube channel. The link for this is given in the description box below. First is Pythagorean theorem and triangle sum theorem. Next is all the geometrical concepts about points, lines, planes, circles, angles and distance and midpoint formulas. And geometrical shapes, properties of quadrilateral and triangles, and volumes and surface areas of 3-dimensional shapes. And translation, reflection, rotation and enlargement of geometric shapes, right angle trigonometry only, trigonometric ratios and solving triangles, and bearings. So these are the things that you should have known under geometry and trigonometry. I hope you enjoyed this video and learned a lot from this. If you have any doubts, please put it up in the comment box below. I'll be helping you with another video if required. Thanks for watching. Happy learning from Ganitika.com. Please do not forget to subscribe and like my videos and share my videos with your friends and families. Thank you very much.